My name's Kevin Ford. I'm a customer engineer at Google. I work primarily on the Apigee API management platform, and I talk with customers every day about their API programs, and security is typically one of the hottest topics. Today, we're going to talk about securing your APIs from attacks. Just a bit of housekeeping. We'll be in presentation-only mode, but you can ask questions in the Q&A panel, and we'll get to as many as we can at the end. Since the birth of the web, hackers have been exploiting vulnerabilities in websites. But over the last 10 years or so, we've seen a meteoric rise in the number of mobile apps. To put it in perspective, worldwide, there were roughly 150 billion mobile app downloads in 2016, generating almost $90 billion in revenue. The explosion of mobile apps is directly related to the availability of web APIs, and I would say dependent on web APIs. The majority of modern web applications also take advantage of the same APIs that power the mobile apps. ProgrammableWeb.com lists over 18,000 public APIs, and there are likely tens of thousands more used internally by organizations or for non-public partner usage. So what? There's a ton of APIs. How does that affect security? Well, when it comes to hackers, the usual suspects are still there, and web APIs haven't changed their motivations. They're looking for financial gain, competitive advantage, even digital vandalism for shock value or to make a statement. We've recently seen bots taking to Twitter to attempt to influence political campaigns. The kinds of attacks are basically the same. What's changed is the attack surface. You know at Apigee, we love APIs. Guess what? Hackers love APIs too. They're easy to program to. They typically expose a predictable resource model. Resource relationships are often navigable programmatically. API documentation is usually available online. Providers often publish SDKs in multiple languages. And finally, we strive to make onboarding completely self-serve where that meets the needs of the API program. So we consider these things generally to be table stakes for an API program, and we help our customers deliver on those promises. But an unfortunate side effect is that the reasons that make APIs great for developers are the same reasons hackers love them. Recently, Instagram's APIs were hit, and hackers were able to scrape email addresses and contact information from millions of accounts. Literally hours later, users' emails and phone numbers were being traded with Bitcoin in a database called Doxagram for $10 an entry. Also, high-profile user accounts were taken over and vandalized. Many of you might not know Moonpig. They're a leader in personalized gifts in the UK. They create personalized greeting cards and gifts from images that are uploaded by the customers. They had a bunch of security issues and had no rate limiting at all. They had to shut down operations completely for several days when a vandal launched a brute force attack. A major hole in their security allowed the client to just enter a new user ID in the request, and they were able to access any Moonpig user account in that way. So because the API documentation was well understood by the hacker, he was able to submit orders on thousands of accounts programmatically. Interestingly, Moonpig was notified of the exposure by a white hat hacker over a year before the attack. The takeaway is, don't assume your API team's on top of it. Leverage the best tools to fortify your walls and make sure your API platform is completely automatable so penetration testing is easy. The Apigee platform has for many years provided security features from end to end that represent API security best practices. If you look at the value chain in this diagram, you can see that we layer security across all constituents from end to end. OAuth 2 policies are there to ensure users and apps talking to your APIs securely. We've got rate limiting policies to defend against DOS attacks. We have quota policies that allow you to define usage limits on a per client basis. These 3 policies would have helped Moonpig. Role-based access control throughout the platform. We have RBAC in the management UI, the management API, and the developer portal. And you can configure mutual TLS between Apigee and your backends, but also between Apigee and your clients. So in addition to that, we have a variety of policies for threat protection that guard against SQL injection, JSON bomb, XML bombs as well. The party is also third-party pen tested regularly, and we have PCI and HIPAA compliant offerings for our public cloud. So just a quick reminder, if you have questions about any of these slides, go ahead and ask them in the Q&A panel and we'll get to them later. So we just looked at some of the security features in Apigee. We talked about OAuth, traffic management, encryption, access control, and some of the other security features in Edge. But even properly configured APIs following security best practices are successfully attacked. A couple of the most common ones we see are account takeover and scraping. I'm not going to go over this whole comprehensive list, but I'll talk about a few, maybe some examples. So account takeover is basically trying to steal the identity or personal information of your users, forging transactions on behalf of users, getting at loyalty programs. Both of the examples we talked about earlier involved account takeover. So anybody can go onto dark nets and buy millions of usernames and passwords. And these are credentials that were leaked through some other attack. When an attacker gets his hands on a list of credentials, they can start a brute force attack and begin credential stuffing against your auth endpoints. Basically, the bot creator here wants to iterate the list of credentials and attempt to gain access based on whatever authentication mechanism is in place. Of course, he knows this because you've got an open API spec that describes exactly how to use your API. Your developer portal might also let him know that he's limited to 300 requests per minute. Helpful information for a hacker. Another one we see a lot is scraping. A lot of APIs have extremely valuable data that's not easy to create. As an example, Yelp has amassed a ton of valuable data about businesses centered around qualitative social reviews over the years. This gives them a big competitive advantage that they definitely don't want to give away. We've seen scraping attacks targeting patent data, retail product data, media sites, and a lot of others. Let's say hypothetically if I could effectively download, by scraping, the Internet Movie Database, imdb.com, I'd have a free copy of an extremely valuable set of data that I could sell to others or use for my own apps and generate revenue off the creator's coattails. So API providers must defend their data because it can represent a significant part of the core value of their companies. I mentioned that even properly secured APIs can experience attacks. A lot of enterprise security teams have CDNs and WAFs in place and naturally put Apigee behind these. Nothing wrong with that. WAFs are well suited for handling some kinds of attacks. So you can see in this example, we have requests coming from a variety of good and bad clients. And the WAF's able to use kind of a machete approach and block some of that traffic, maybe based on IP address or the region they're in. So what we've seen is that a lot of traffic still gets through. And that traffic, in order to handle it, you need some more context. You need context from the metadata in the APIs. So because we're in the critical path of the API traffic, as an API proxy, we can leverage that metadata with context over time to detect and mediate against these threats. And you'll see that using these contextual indicators and all of the lessons we've learned around them, we can detect against those effectively and identify potential bots that get through other traditional technologies. So it's important to realize that web security and API security are not the same. It's a completely different programming model, different attack vectors. If you're running an API program and you care about your users, your reputation, you need security that's purpose-built for APIs. All of our customers currently enjoy access to a full suite of security policies and best practices to lock down their APIs. As an additional layer of defense, we introduced Apigee Sense, which is intelligent bot detection. Apigee Sense protects your APIs from bad bots by automatically identifying and alerting administrators to suspicious API behaviors. Administrators can take action to maintain user experience and protect their back-end systems. We don't just alert, we also offer flexible, automated remediation. And I'll dig into what I mean by flexible remediation in a bit. What you're seeing here is a threat map in Apigee Sense. It's on the UI visualizations, one of the UIs in Sense. So I removed the customer name, but this is a major API provider experiencing an account takeover, and this was captured yesterday afternoon and ongoing. So hackers reverse engineered one of their apps, and we're using the API key to attempt to take over users' accounts. It's not dummy data, it's real traffic, just anonymized for the purpose of inclusion here. So Sense is built from the ground up to understand and protect APIs. It's the only product that offers comprehensive behavior-based detection. Many of the largest API programs run on Apigee, and that's given us a great insight into API patterns that signal bad behavior. We're the leader in API management for such a long time, and it uniquely positions us to understand all kinds of API traffic from every vertical. We run 1/3 of Fortune 100 companies, 2/3 of the largest telcos worldwide, and 60% of the largest retailers in the US. It's not to brag, it's just to make it clear that we have a ton of experience working with all kinds of APIs. And finally, it's a closed loop. Apigee detects the behaviors and you decide how to act on it. In a typical scenario, an administrator gets an alert and that there's something suspicious, and she goes into the Sense console and maybe looks at this visualization and to see the potential bots and where they're coming from. She can then drill down into what types of bots they are. Are they credential stuffers? Are they brute force guessers? Whatever caused the trigger for Apigee Sense to highlight the potentially suspicious traffic. Then she can decide to block it if it's determined that it's a bad bot. Maybe you want to allow it if it's not a bot. And there's also the case where it's a good bot. This might be a partner running programmatic queries against your system, and that might be fine. And additionally, you can flag it. And we'll talk in a minute about what that means and what that enables you to do. But the key here is that you have different ways that you'd want to act against different bots and bad traffic. So why is it better? Apigee is already capturing all of the API metadata as it flows through Edge. Apigee Sense studies those call patterns and identifies aberrations. And it's unique to each of our customers, and you can tune your own rules for detection as well as defining behavior specific to your business. So it all runs in the background, and your devs and admins can focus on the business and not worry about it as it runs. So we analyze traffic in real time and trigger alerts automatically. Sense finds anomalies from baseline traffic behavior and learns over time about your traffic. When these anomalies happen, threats are identified proactively based on built-in algorithms, and you can tune them as necessary. In a nutshell, as traffic flows through, the analysis engine examines API request metadata. Based on the metadata, contextually over time, requests are categorized, identifying the request that looks suspicious. And some examples of how we categorize suspicious traffic are unusual error rates, unwarranted repetition, parallel attempts at the same resource, data crawling. In a data crawling example, you might have a single client accessing 1,000 items in your catalog, which is starkly different than the way a human would browse your catalog. Username and password space searching, automated form submission, key harvesting. There are a ton of different types of activities that we can categorize. Once we detect bad behavior, administrators are immediately alerted and can take action. So your administrators decide how to handle suspicious traffic. And this is a key difference when you compare it to traditional methods where the decision is made for you that this traffic is blocked. So once you confirm the behavior highlighted in Apigee Sense and you decide what action to take on that traffic, Sense will immediately enforce that rule to allow, block, or tag the suspicious behavior in real time. So just wanted to repeat that in stark contrast to systems where traffic is suspected to be bad and automatically blocked, you have an opportunity here to figure out and decide how you want that traffic to be handled. So I mentioned before that the protection happens in a closed loop. All of what you see in this loop is happening asynchronously as traffic flows through. So we're already collecting analytics data. So Sense takes the pieces of that metadata that are relevant for its detection, pulls them out, analyzes them, and then does what I mentioned before, categorizes them into groups of suspicious behavior. Once that's happened, if suspicious behavior is found, it's visualized and surfaced on the Sense console, and there's a number of visualizations that let you look at it globally, regionally. You can look at specific patterns that you're interested in. So you can drill down in a number of ways to figure out what the traffic looks like and see detailed information about all those requests. And at that point, you have an opportunity to make a decision about how to act on it. So you implement that action in the Sense console, and that action is then enforced automatically for all future traffic. So this happens in a closed loop, as I mentioned. It's asynchronous, and the enforcement is automatic, and the notification and alerting is immediate. I talked a little bit, I mentioned a couple times flagging requests or tagging requests. So you might not always want to block bad traffic. And let's just use one example. There are dozens of them, but use an example of a price scraper. So if I detect that there's a bot scraping prices on my catalog, if I block the traffic, immediately that bot's going to find some other way to come in, and then I'll just have to find them again the next time. An alternative approach might be to send them erroneous data or stale data. You can route them using, and this goes back into some of the flexibility in the Apigee platform. When Sense flags a request, effectively that sets up context that you can leverage in all the standard Apigee policies. So I can do all the things I can do in Apigee. I can conditionally route to a different backend if I want. I can make a side call to another service to determine how to respond to the request. I can log it into any type of syslog compliant backend and then act on that. Perhaps I have a different kind of alerting that says, well, now I've identified the traffic, let's flag it all and then start alerting so we can look at them individually. There's a variety of things you can do, but the net here is you can use all the policies and capabilities in Apigee to respond to the traffic instead of just blocking it, and using a machete approach. You can apply a scalpel and, act the way you like. And the reason you see two kind of sides to this is everything I just mentioned can be done via drag and drop policies, and our customers that are on the call already know this, but just for those who are new to the platform, we have policies you can drag and drop and just configure to do all these behaviors I mentioned, or you can write code in a variety of languages and extend the platform with your own custom policies to handle those situations. So I'd like to just quickly tell you a little tale of two API providers. So this API provider is pretty secure. They're using Apigee, of course. The walls are built with OAuth to keep out unwanted traffic. You can see they've got a front gate here that's going to throttle traffic a little bit as well. But there's a problem. They've got no visibility. And without visibility, you can't be secure. If I wanted to take this castle, I could send thousands of attackers through the forest, and they're hiding under the trees. Nobody sees them coming at all. They're chipping away at the walls, looking for broken bricks, weak spots. They're hammering away, and they can do it in their own time because I don't see them. They're also trying to scale the walls. They usually fail because I got pretty high walls, but if they do make it over, you probably won't even see them. And now they're cruising around the halls inside the keep, and they're in. So this provider, they're doing all the same things as we saw in the previous example, but they have visibility. They cleared out all the trees, and now they can look ahead and see attackers coming a mile away. This is what Sense provides you, visibility, so you can see attackers as they're attempting to penetrate the walls. They've also installed a moat and a bridge. Expands their visibility. Nobody can get close. They know when you're coming. They've dramatically increased the visibility. It's a key step to enhance security. The only thing they're missing is the last component I mentioned, automatic enforcement. And of course, the archers are fully automated and rule-based. I just wanted to wrap up here. My goal was to talk about some of the threats we see today. And as we run massive amounts of API traffic, talk a bit about security best practices and how Apigee Sense can provide intelligent security for your APIs. At this point, I'm going to break for some questions. Okay, so the first question is, does adding Sense to the API edge create any impact on API performance? So, as I mentioned, it's negligible. You take a negligible hit because we do actually enforce. So imagine if you in your API platform wanted to block traffic and reject it. That's effectively the same as implementing a simple policy. So enforcement is well under 10 milliseconds in all the cases we've tested. Everything, all the heavy lifting is done asynchronously offline. So next question is, does Sense look across all customer data to identify malicious patterns? So we don't look across all customer data. We don't, most importantly, we don't commingle one customer's data with another customer's data. We do, however, and have, however, leveraged the fact that we've processed traffic for hundreds and hundreds of major platforms. That learning is something we have, and has helped us to build out the models and give us really deep expertise in how to, what types of threats we need to be considering. So no, your data is yours. It's completely, in our multi-tenant model, it's completely siloed off for you. We don't share it with anybody else. I got a question coming in. Is Sense mapped to any policy? So Sense has its own interface that allows you to configure both the rules. You can tune the rules. That's kind of a setup phase. And then once Sense is running in your organization in Apigee, you have a visualization interface as well, where you can go and see the traffic that's being detected. What is it finding? What types of attacks is it surfacing as suspicious? That's the second interface. And then they're all one interface. It's a cohesive interface. And just say the three components of it. That visualization piece is the second. And then you have the ability to act on it. Again, this is all in the Sense UI. And you go and say, for instance, I'd like to block traffic that matches this pattern. Now, the only way it's really mapped to a policy, and when you say policy, for those who are not very familiar with Apigee, I believe you're meaning an Apigee policy that allows you to alter traffic as it passes through the platform. So in that example where I mentioned that you can flag traffic, if you've decided you don't want to block it, you don't want to allow it, you want to flag it so you can do something else, that's where the policy comes in. So when you flag it, Sense adds a header, and then your policies you can write policies that conditionally respond and work with that header. All right, another question I got, is Sense available for on-premises customers? So no, Sense is available for edge public cloud customers, and it will be working also with hybrid cloud configurations as we go forward. Okay, next question. Can this be added at the proxy level? Meaning, can I choose which APIs need to pass through this Sense flow? The answer to that is yes. You can configure Sense to only monitor particular proxies. So I see some very specific questions. We'd love to answer those, but we'll need a bit more information. We'll reach out and address all of these. Last question here. Is Sense available to all customers, or is it something limited to enterprise? Enterprise. Yeah, it is limited to enterprise customers. All right, so we're going to wrap with that. We've received a bunch of good questions. Some of them are very specific. We'll be reaching out to all of you for some more details. And I wanted to encourage anyone who's interested in seeing Sense demonstrated, whether you're an Apigee customer or you're interested in becoming an Apigee customer, to reach out to us. You can do that through our website, reach out to Enterprise Sales. And we will, as I said, we'll follow up with the questions and get details where we need them. But lastly, you can also, for some of these questions and any other questions you have around Apigee, you can visit community.apigee.com.